again for joining another month of our ClearCalcs webinars, ClearCalcs Learn Hours. Apologies, we're starting a couple minutes behind here. I'll take the blame for that coming off a demo. But thank you again for joining. We'll give it about 30-ish more seconds for people to join, but because we're already a couple minutes behind here, we'll probably begin pretty soon. As you guys may or may not know, if you've attended some in the past, please send through maybe name, what your job is, architect, engineer, designer, and maybe where you're joining us from. See about 25 joining right now. Again, thank you guys all for joining. You can go ahead and put that in the chat. So now that it is 11:03 my time, at least, we'll go ahead and get going, so that way we can make the best use of your guys' time. As you guys can see here, it's myself and Eva. We're kind of confusing because I'm showing up as ClearCalcs and she's showing up as me, but that's all right. Today we're going to talk about some time-saving tools within ClearCalcs in particular, because in some past webinars, we've gotten quite a few requests and great questions about how you guys can be both most effective and become ClearCalcs experts yourself. So we're going to have a resident ClearCalcs expert, Eva, walk us through a couple of these tips and tricks.
Yeah, I guess just a little bit about ClearCalcs. We're for anybody potentially new joining us. We're a web-based design, cloud-based design, so all of your work is automatically saved and you can access us from anywhere, including your phone and tablets. We don't recommend it for now, though. We're going to work on that one in the future. What sets our calculators apart include our live solutions, our finite element analysis, and yeah, as simple as or as complex as you want. And some of you, if you've seen our new simple template, will have seen that, yeah, we're working on streamlining the process and as well as building in new features. And we have really nice exports that I'll go over how we can get through. And then, yeah, any product and updates. We'll give you a little sneak peek of what's coming in the near future as well. I'm happy to take any questions at the end, or feel free to send them through. Yes, so this is how to ask questions. On the side, there's a questions tab, or and Connor and I can, either of us can take those. So today's agenda include project setup, project defaults, adding preferred sections, organizing our calculations, linking a load, calculation upgrades, changing design material, hassle-free Excel-like calculations, and unit conversions in case some pesky Canadian gives you some metric units. You can do that right within the platform, and exporting to Excel or CSV file for transferring into your contract documents. I know this seems like quite a lot of things. I'll try to go through them fairly efficiently, but we also do have a webinar from a couple of months back that we can link to you for specifically about project defaults and load linking, and we're happy to send out that link as well. So this is more of a high-level overview of things that we can do. So starting with project setup and project details, you can set up the project name, number, but really most of these are optional, and the most important parameter here is the building standard. I know it says Australia right now, and the unit system. So actually, I'm just gonna head over to our tab and show you guys how this is done. So if you're working in the United States standards, you can set them here. But if, say, for whatever reason, you have a Canadian project or European project, you can set those too, as well as the unit system. So once a calculation is made, the unit system is set, but before then, you have the choice of metric or imperial units. That's pretty cool. And then from there, we go into setting project defaults. And our project default values will apply to any new sheets you make within that project. And these sheets will automatically update, as you can see in the gears on the side, to reflect these project defaults. And we'll go through these defaults in a bit more detail in the next couple of slides. So in the project default, we have geometry, where you can set the geometry of your height, any heights, or any like default. Basically, any default numbers can be saved here, and much like a worksheet on an Excel workbook, you can actually pull these numbers via this specific code. So project default, open bracket, and then the formula reference. And you can pull this into any of your existing calculators. I can actually show you that here. So let's go into our project defaults. The one I find most useful is usually like the loads, the live loads, and so these roof loads. So when we start with a wood beam, and let's say we start with a rafter. So all of the loads from project defaults are already being pulled in from there. And if the project default changes, then these loads will also be, the load will update automatically, which is fantastic. If you, if say you decide you need like extra dead load on your roof for heavier tiles, then you can just update it once in the project defaults, and all your calculations will update. And then we can set our geometry here. So a little bit of explanation on what each of these geometries mean. So the rafter and joist spacing will set the tributary width, so the load width of distributed loads. The bearing length was basically for beam supports. So for example, for timber beams, our bearing length will tell you, show you where it is. Our bearing length will be set, it's set here, and then they actually occur. So just in the last template I was in, waiting for this to load. So this is pulled right in from there. So if you have a default bearing length that you like to use, that's where you can set it. And so in case anyone was wondering where the 3 came from, it comes from the project default and can totally be overwritten. And then we have headroom. So headroom actually just defines our stud height. If you define a stud, we'll just put in our default height will be referenced from here. And height above the window will reference the lintel load width. So if you make a lintel, these numbers will automatically be populated into that template. Then for the loads, so we've talked about this a bit already, but we have the loads that you can define here. And then we have the design code. So by default, we usually go into IBC 2018. If you have a grandfathered project, you can go into a previous IBC, for example, IBC 2015 or 2012. And then we also support all recent versions of the IRC and ASCE 7 as well. And if you have any, like for example, bespoke projects where the serviceability criteria is not quite standard, you can set custom load combinations. And down here we can see these are all set as you can label them and then define what the load what the factor for each load parameter is. And so as that happens, every project in your every template in your project will be updated. And then we have a place for uploading wind load. So wind load, if you know where your wind load is, we recommend that you can implement it here in the ultimate window and wall loads. And these are just loads that will be applied on columns and on studs that are defined as exterior studs. So by default, we have them set as 30 PSF. But if we want to get a little more specific, we can actually go into our wind loads, cladding and components and calculate these. And so we can see from this chart, the wind pressures for each zone. So if you know which zone that most of these calculations will be designed for, you can actually go ahead, read off the number and just type it into the project defaults. So yes, and we'll work on a way to link those so that we can have them import more efficiently between the calculation and the default numbers. Next up, we have, if we go back to our details page, we have preferred sections. So our preferred sections is usually used for, it's most commonly used for our auto size feature, but what we found that actually some users like to use it just as a list of common sections that they like to use, and it makes it really easy to find. Actually, I'll just show you guys how to add the preferred sections. So you can either add them fresh for this project or copy them from another project. Just go ahead and add those. You can have preferred wood sections or preferred steel sections. Let's do these for now. So these are kind of the really large sections. We'll move a little lower on the list and say, I like these sections, the W12s and maybe W14s, the lighter ones of the W14s. So done. Now we can go into any of our steel calculations, steel column. And then we can use auto size. So auto size will give me, so a W12 by 19 is a preferred section of mine, and so it auto sized into a W12 by 19. Or alternatively, all of my preferred sections are right at the top of the list. So you don't have to scroll through many pages of sections to find the sections you want to use for this project. So this comes in pretty handy for finding sections. And of course, you can also find any section by typing in the filter. I want a W16, and this will give me all the W16s. And then from there, say I've designed a bunch of sections, and now I want to organize them and group them. And also I want to make sure that I don't have a one-off section like, we can go to the member schedule and we can actually make groups. So if you know that you have a bunch of rafters, ridge beams, and other members for the roof calculations, you can group them by roof. Or you can honestly group them by anything. You can say all steel beams or all timber beams as well. For now, I'm going to call these roof framing. And we can drag and drop. So this is admittedly a little finicky. You need to drag the little plus sign on the side. You can drag and drop them here. And so, yeah, let's drag a couple here and say, these are my, that's a concrete beam. And let's say these are my roof beams. What's also nice is you can edit the member straight from here. So if you notice, hey, I'm using 5 and a half, sorry, by 16 and 5.5 by 16, but for some weird reason here, I'm only using a 2 by 10. Maybe it makes sense for sourcing that I'm just gonna have all 5.5 by 16 for easy construction, right? Or for connections. So you can actually edit it here and double check 5.5 by 16. Probably really doesn't need to be this large, but we know for sure that this member will work. And you can edit it right here. Just pick that. And you can see this updates and the percent utilization updates as well. So the member schedule is quite powerful for double checking all the members, the quantity and the utilization calculation all at once.
Hey,
and the next one.
Eva,
Yeah.
sorry to interrupt here. I just got a great question from Heather. So you ran through the project defaults and just throwing in maybe like default roof loads or ceiling loads or things like that. Can you just show once again how when you then open up, say, a roof header calculation, for example, that's going to pull in those default loads for the roof or ceiling or anything like that you put into project defaults?
Yeah, for sure. So if I understand, like, how can we confirm that these numbers are being pulled into a calculation template? Right?
Yes, exactly.
Yeah. So reset. So if we add a new calculation, and we say we want a rafter, so that's a roof beam, we will automatically pull in the roof loads. And so to confirm that, if you open this, when you click on it, it should pull up with project default. And then WDR stands, I believe DR stands for dead roof, and W stands for weight. So weight of roof dead load. And this is usually the minimum. So if this number, like WDR, is not defined, we'll just by default put in 20. So it's the minimum, sorry, not the minimum. We pull in this number first, and then if this number doesn't exist, we'll pull in 20. And actually that's why you'll find if you start a generic beam, we'll start with 20 and 40. And so these formulas are all here for your reference. So actually, if we want to set WDR, this should now also reference 15. Does this help?
Yeah, I believe so. And I think Heather just sent through a follow-up question. I think what you're doing right now is really what's touching on her question here. The ability to type in what you're seeing in that field, project default, and modify either the variable or the load itself is how you'll then bring in maybe a default load that wasn't by default in the template.
Oh, that makes a lot of sense. So how do we, that's a great question, Heather. How do we know what what it's called? So I think if you click on this, it says W, so actually that's a straight reference. This is a great question. We should find out how these are defined, but believe. So the table ones, actually I'll bring this back to the team, but the table ones are for some reason hidden. But if say you wanted to reference number of stories, you can reference n-story. And default bearing length, you can reference LB from the project default. So actually I'll show you here.
Yeah, that's a good question there, Heather, with referencing the loads. Like Eva was showing, it looks like for some of those, the loads themselves have associated variables, at least the roof loads, ceiling loads, floor loads, that stuff. So you can reference those in the format that is in where it says project defaults, parentheses, comma, all that fun stuff. But yeah, that's a very good point. Eva and I will take this back to the team and confirm why some of them have a straight number and some of them have variables.
Yes. Yes. But I guess going back to the other question, if for some reason you wanted to set the absolute deflection limit as your default bearing length instead, if you pop this open, you can see it's called delta hard. So this really should exist for all of them. My apologies. We'll go back to the team and make those more readily available. But you can reference delta hard here and pop this open. And then instead of putting LB, paste in delta hard, and that will reference the 1 inch that we saw from the project defaults. So as long as, so the key here also is that the units have to match, or if the units don't match, like math, which we'll get to, like Excel style math, will have to be used to kind of make the units match. Actually, that's a great point, and that brings us, I believe, to our to one of our other slides. So I'm just going to quickly flip through some of our other things. So I think most of you guys know about load linking, where you can link the reaction loads from a beam or a column and place them directly onto another member. So for example, we have this beam and say we want to add a point load of, say, actually supporting a steel column doesn't quite make sense, but say this steel column was supporting the wood beam we just designed. What we can do here is go into link and find B19, And then it'll show us either the left-hand side support or the right-hand side support, which doesn't matter in this case because it's symmetrical. But if you had trapezoidal loads or triangular loads, then just have a look and make sure you're referencing the correct reaction and put that in. And then you can see that this is referenced to B19, I believe. And then if you click on it, it'll bring you to the beam that it's referenced from. So that's a neat trick to know if you're ever looking for the link and you're wondering why, okay, I wonder where these reactions are coming from. You can just click on the label here. And then, yeah, one quick thing I wanted to touch upon is calculation upgrade. So we're constantly upgrading our templates, either to fix bugs or to add more features. And you can actually see exactly what we've done in that fix in the change log. And if you click on the change log and think, oh, I don't care about this change, you can actually uncheck it. So you don't have to upgrade that. So you can bypass the calculation upgrade if you wish. We do recommend upgrading all critical bug fixes though, and usually even the minor bug fixes as well, especially if it's a calculator you're looking to use. And any new templates you make will be the latest version of our template. And then, so we also have the feature that allows you to change materials quickly. Like for example, say by accident or originally this column was taking a lot of load and I designed it as a steel column. But actually now after some iterations, I found that it's only at 3% utilization and it really is overkill for it to be a steel column. Can go into change material and say, let's change it back into a wood column. So that'll carry over all the loads, length, and any parameters that you've put in that are relevant to the wood column. And so we can see here, we carry all the same loads. And the same length of column. And then you can size it from here. And actually this is still very underutilized. You can use auto size or select a size that will work. That neat handy feature. And then actually, yes, so this is the Excel-like calculations and unit conversions that we can do in ClearCalcs. So Heather, just getting back to the question about linking things. So basically, think of project defaults as kind of like as one worksheet within your Excel workbook. And we're just storing numbers here that we can pull into any of our design worksheets. And so if we have, so any of these numbers, if we have, say, PSF, oh, wait, I can't reference that one yet. Say I have the roof slope, so the alpha roof ratio is 6 to 12. I can reference this as long as I know the units and I can perform any type of math on it. And then the other cool thing we can do is if we go into our loads and say we have a projected load for some reason, our snow load is projected. So we can take this and just multiply it by the cosine of theta. That is not the correct reference. But if we know what the reference is, we can say we want to multiply it by 23 degrees. And that will actually give me the horizontal projection of the magnitude per area.
Hey, Eva, would you mind, bless you, sorry about that. Would you mind zooming in and just showing that formula field that you were looking at just now with the cosine a bit? Just a bit closer.
Yeah, of course. Sorry, had to cough. Yeah. So yeah, you can take, so this references the project default, and then we've multiplied it by the cosine of 23 degrees. Alternatively, we can what we can also do is we can replace the project default with some PLF or apparently some pesky Canadian has given you kilonewtons in kilonewton per meter squared. You can actually put in like 1 kilonewton per meter squared, I believe it will work. And then that should do a conversion. This is very specific to kilonewton. Your N in kilonewton has to be capitalized. But say somebody said, hey, can you put in 1 kilonewton per meter square of snow? And we don't want to do the calculation, obviously. You can actually just pop it in here, and that will do the calculation. And so this, we know the conversion from kilonewton to PSF is 20.9. And then you can do any type of math you wish. You can multiply it by 2. So anything, if you don't put in a number, we'll assume it's unitless. And then the cosine of 23, of 23 degrees. And you have to put in degrees, otherwise actually by default our trig functions come as radians.
Then another thing there, Eva, and this is all super helpful, just with the reference there with the 23 degrees or the reference code that we can use, for lack of a better term. If we put in incline there, I believe it should work. I believe that's the reference code, not theta, but incline.
Yes, so actually, good point. Thank you, Connor. If you go into detailed mode, more parameters will show up, and we'll see that 6 to 12, we actually do the calculation and show that this is 26.6 degrees, and the formula reference for it is incline. So thank you, Connor. What we can do here is just put in incline, not theta.
Perfect. I won't claim to know that off the top of my head. I just looked into our help accordion mode there. So just a reference for everybody, anytime you have a question on what the formula is, if you just expand the section, you'll be able to see what the verbiage or terminology we're using is.
And then you can search here too, if you wish to, if there's anything specific you're looking for. And if you can't find it here, please feel free to use the ask function and pop us an email. We're happy to, take any questions or requests. Is there any other questions? I feel like this one is, I think if I were, when I was a structural consultant, I think this one is something that I would have been super interested in using and knowing how to use. Oh yes, and then common constants such as pi and e are built in. Are there any other questions, I think, about Excel-like calculations or like how to use kind of these references?
So there's none that have come through yet, but anybody that's watching here, if you guys do have any questions, maybe potential use cases, feel free to send through. And as Eva moves on with the presentation, I'll be sure to bring it up during the Q&A section.
Then moving on. So, and then we can export. So say you've made a bunch of calculations, you can then export them to a CSV or an Excel file. And you can use it any number of ways for quantity takeoffs or such, but we also, actually I'll show you, but we also export the end reactions, which I find is useful for basically copying it as a column and pasting it straight into my design drawings. And I know there are Excel to CAD conversions, Excel to Revit, like Dimlink is a Excel to Revit conversion. And even I think Bluebeam as well. I think you can just copy paste directly. So I'll show you how to make this export. If we go into export here, the export button here will export just this page. But if you go to the export button on the side, you can select all members. And this will just automatically select everything. For the sake of I think time, I'm only going to export just the roof framing ones. So we're not exporting all 7D sheets or 20 sheets, and we'll just export as Excel. And then that will generate a member schedule in a CSV file that you can use. Just open that. And it will look basically identical to this. So this is the Excel sheet that was exported. And we can see the parameters include quantity, the quantity unit. So whether it's in, like for concrete, we'll reference it in cubed in metric, in volume, sorry, yards cubed, and then for length, we'll reference in feet or inches. And that's it for our existing features. The next slide will take a sneak peek at our new features that are coming, and we'd love to hear your feedback on it. So in the Australian side already, we're looking to implement kind of built-in code references into our platform. And so, for example, here you can see code reference. The Australians use Australian Standard 4100. And then when you click on it, you can see basically this would show the IBC or ASCE 7, whichever is relevant. Yes, and then you'd be able to see exactly how we calculated this and where this reference comes from. We'd love to hear your thoughts on it, and if this is something you'd be interested in seeing, or like what other features on top of this would be super useful. The other feature that we're looking to implement in here is also like allowing commenting. So if you have a question for, say, your senior, or as a form of communication about this between project engineers about this particular clause, such as for clarification, we also have a comment tab that will allow internal communication for that. And then as a power-up, please feel free to send us any of your feature requests. We do track every request. We have one very large sheet for tracking it, and we look through every single one of them carefully. And the more requests we get for the same feature is how we prioritize it. So if you have a feature request that you really want to see, please send that through at help@clearcalcs.com. Yeah, and thank you for coming by, and yeah, happy to take any questions.
Yeah, thanks for running through that, Eva. Quite a few, or not quite a few, but a few questions that came throughout that were really great. Thank you both, Albert and Heather, and everybody else that sent through questions. We do have a bit of time here. This was a bit quicker of a webinar just because it was focused specifically around ClearCalcs and some power-ups we thought might be useful. So if anybody does have some additional questions, I see a couple coming through here from Heather, so I'll make sure to check these out and before I bring them up to you, Eva. While I'm reading Heather's questions, just to for the sake of showing people some more power-ups, do you want to just show how to do like a quick swap material workflow, so that way people can see how, if they're designing, say, a wood beam, they can just quickly swap to a steel or something else to save themselves time?
Yeah, sure. So yeah, if we add a new calculation and we open up, say, a wood beam, and we use, I think a common one would be a ridge beam. So say you have a heavily loaded ridge beam. You can add, if you have an intermediate support or anything, you can add a support at midpoint at L/2. And then you can set a project default bearing length. And so you see, actually, as you update this, all of your positions will update. And then so actually we're at pretty good utilization, haven't defined the loads yet. So let's put in our loads, and we can link our rafters into into here. So from our roof framing, we can make it B1. We can reference this from 0. So now this is getting into pretty high utilization. And then actually this has actually happened to me for the architect decided that a column in the middle is no longer acceptable because now like they used to have a partition wall and now they don't. Now the client wants an open space and they say, we can't have this column in the middle. You knocked out the column in the middle and the bending utilization is way overutilized. And for this particular span now, we probably want a steel beam for more efficiency and to not exceed the depth. So we can go here. It's like the little swappy thing, change material, and we can change it into other types of beams. So in this case, a steel beam. You can change it into any other type of beam. I think the only caveat is you can only change it into beams of the same like code. So we started with a US beam. We can't change it into like a different Canadian or an Australian beam. So we can only change it into another US design beam and change it into a steel beam. And so here, so now now our ridge beam works. It's still 24 feet, and we still have all the loads that we used to have. And any of these parameters will carry over in the change materials. And then here we can look to optimize. So we can pick from our preferred sections, which will always come in from the top, or you can keep scrolling into larger or smaller sections. So I think that's one example of how I would use a switch material.
Yeah, that example is awesome, Eva. Another one I've found is even if you get to the point where you're all the way at the end of the wood beam design, for example, then you swap to steel. I've seen a lot of our power users just off the bat design wood and then use our duplicate feature to create an exact copy. And then they could have like a wood beam, say a flitch beam, and a steel beam, and just submit all three of those options right away to their client or the permit reviewer or anything like that to make sure that they're all reviewed. And then they could basically use that information to figure out what's the most economical or most aesthetic solution for their case.
Yeah, for sure. Thanks for reminding me of that, Connor, actually. So we can label this as B20 steel. And the duplicate feature Connor was talking about is up here, right beside change material. If you duplicate, you can rename this as wood. Now we can make this change into wood. So then you can have multiple B20s of different materials, and you can see, and then you can you can hover over them and compare their depth and utilization. Here it's not currently passing, but if we used, say, a larger section, so we used one of these, then we can actually just compare the members between the two and the utilizations pretty quickly.
Awesome. Thanks for showing that, Eva. So for everybody still in, it looks like we still got about 21. This is about it that we had, like I mentioned. We have a few more minutes, so if you guys do have questions, send them through. And also, if you have some deadlines to work on, anything like that, feel free to hop off. Don't want to keep you guys on. The last thing I do want to just take the opportunity and the time to chat about is, Eva, if you'd be able to just show the new template, the simple wood beam template that we recently released. Only because we've got a few questions through our support page, people opening up the simple beam template, thinking that they were opening up our classic wood beam. So just kind of touching on what the capability differences are between the two and just maybe show the difference in interface and potentially even touch on why we made the decision to offer this as an option.
Yeah, of course. So the so yes, it has kind of replaced where the wood beam used to be, just as a heads up. If you're looking for wood beam, it's now the second option. And you'll find actually when you click wood beam, it'll have presets. Whereas when we open simple wood beam, it'll just go right into the template. So kind of going over why we made this template, we were finding that in the standard, especially for first-time users, we were finding the standard one was causing kind of unnecessary confusion. There were a couple of things, such as like the summary just quite literally overflowed, and it was hard to tell what the reactions were. Because we couldn't see the original the free body diagram, but wanted to prioritize that for this one and make sure that as soon as you open it, it's obvious that this is a wood beam calculation. We also put in just distributed loads. We find that for most calculations, distributed loads are really what users use. We did keep line loads and point loads. Mostly actually for linking, we find that the most used for line load and point load feature is the linking feature. And this kind of just this reorganization we wanted to test out basically to see if it could help users design being faster, right? So this is zoomed in, sorry. It's just at 100% zoom. Really, anything you could need to design a beam is all right here. And I wanted to help minimize scrolling. I do realize our traditional beam template has a lot of scrolling sometimes. And for a pretty simple beam, you can design right from without having to do any scrolling. And so this was the approach I came at it from. And then you define your distributed loads, your self-weight, and that it's continuously braced. We did limit a lot of the considerations. So it can only be, for example, it can only be dry and it needs to be less than 100 degrees Fahrenheit. We only support strong axis bending in this. But really what we wanted to do was help users be able to design a beam without having to do so much scrolling. Especially if you're designing a lot of these, it feels like it's kind of unnecessary to constantly like have to scroll down, find what you're looking for, input it in. So I wanted to put them all on the same page. So of course, if you find that there's not enough feature, what you can do is you can start from here, define your loads, define your supports, and even define the size and grade. And you can actually just change material into our standard wood beam. So if you find you've started a simple beam and like, hey, it doesn't have all the features I need, please feel free to flip over to the wood beam. And would love it if you sent us an email as well, just saying, hey, I wish you had this feature in the simple beam. It's something that I use often. And otherwise, yeah, it's really to help allow you guys to design beams faster and more efficiently with everything on one page.
Awesome. Thanks for going over that, Eva, because I know, like I mentioned, we just got a few questions like, hey, what's this new template? So thanks for touching on that. Heather had a question here. This would go back into our, I guess, classic wood beam template. Can you just show how on the right-hand side, when you're looking at like the shear moment deflection diagrams or graphs, how you might change what the graphed load combination is to include certain types of loads in the shear moment deflection calcs?
Yeah, so our graphed load combination is, is unfortunately like static, so we don't automatically pull the relevant one, so it can be defined right here. And you can see it has all the loads, so it starts with all the load combinations, and then we go into serviceability loads, and then all the unfactored loads, like if you wanted to see just live load, because for serviceability or just live load for shear, then you can define it here. And to find out, like, but if you want to say, look at the governing combination to find out what the governing load combination is, you can actually open this and go into detailed mode. And so then we have the whole list. So we can see that the shear forces and the moments are listed here. And that actually the adjusted positive moment, the maximum is 37,000 pound-foot. So we find 37,000 somewhere here, 37. It's the D plus H plus F plus 0.45, wind plus 0.75 live. We can go up here and we can look right here. So the D plus H plus F all includes that already. So we can pop that open, and this is more or less the envelope case.
Thanks for showing that. And one just piece of clarity. So while Eva mentioned the graphs themselves are defaulting to just D plus L with the envelope there, and you could modify the graph load combination, be confident that the actual results more at the top are pulling from your governing load combination. So it's not by default checking your beam or whatever through D plus L. We are looking through all the load combinations and analyzing it, designing it for the worst case, but the graphs themselves are defaulting to D plus L, and you can modify those if needed.
Yeah, thanks for that clarification, Tanya. Yeah, all of our calculations automatically pull the worst case scenario.
Yeah, thanks for that, Eva. Thanks for the questions, Heather. Those have been really great questions, and I'm sure questions that multiple other people have as well. So we have about 10 minutes left, but I figured just let everybody go 10 minutes early. I'm sure everybody has things they could be productive on. Thank you all for joining. As always, send us emails if you guys have any feature requests, if you have any questions, any friction points you're coming across, anything like that. I hope you all know this, but if you don't, you can click the blue help button in the bottom right-hand corner. And then when that pops up, you can click ask, as Eva has done, and you could email us directly. I get these, Eva gets these. You'll be able to touch base with our structural engineers directly. So hope everybody has a great rest of your week. Have a spooky Halloween on Monday. Have a great weekend, and we'll talk to you guys next month.
Thanks, everyone.